Alright, so in this video we go over section 7.4 trigonometric identities. In this section we're going to put together the algebra with the trigonometric identities, and in order to simplify certain expressions that are a little bit complicated into simple ones by manipulating them using the trigonometric identities that we have learned throughout what we have of this couple of chapters in trigonometry. And then we are going to establish identities using, well, of course, the same techniques as in here. Alright, so first of all, let's recall the basic trigonometric identities. Well, we have here the reciprocal identities. Well, cosecant 1 over sine, secant 1 over cosine, cotangent 1 over tangent. And then we have we're going to name other identities. Well, yeah, these are called the quotient identities, in which tangent equals sine over cosine, and this comes from, you might remember, the tangent equals y over x, where y is the sine coordinate of the point in the circle and x is cosine. Cosine is the x coordinate of the point in the circle of radius r, and cotangent, well, is it the reciprocal as we saw it here. Well, that will be cosine over sine. All right. And then we have what we call the Pythagorean identities, and those are the following three: sine squared plus cosine squared equals 1, tangent squared plus 1 equals secant squared, cotangent squared plus 1 equals cosecant squared. Actually, these two come from manipulating this one right here. Actually, at the end of the video, I'm going to show you how to deduce these two. Well, I mean, in the well, of course, we have the even odd identity that will come in handy in this section as well. So I mean, just recall that only cosine and its reciprocal secant are even functions. That is, we evaluate them at a negative angle, the negative disappears. The remaining functions are odd functions. That is, they are, well, geometrically speaking, these are symmetric about the origin. All right, and in this case, of course, when you evaluate these four functions at a negative angle, the negative sign does not disappear. In fact, it goes outside. All right, as you can see, for sine, cosecant, tangent, and cotangent. All right, so what are we going to do here? Well, in this case, we are going to basically make use of these four techniques to manipulate expressions, to simplify them, or to establish identities. Those techniques are going to be the following, such as rewriting a trigonometric expression in terms of sine and cosine only. That typically is always a good first move to go about these simplifications. You know that, and that usually that usually is done when we have expressions that depend on tangent, cotangent, secant, and cosecant. Well, not always, but most of the times comes in handy. And then multiply the numerator and the denominator by a ratio by 1. Well, in this case, what we do is what we call typically these conjugates, trigonometric conjugate. You'll see what about this. And then sometimes we write sums of trigonometric ratios as a single ratio. Well, you'll see what about that. And factoring, right? We're gonna look at some of the factoring techniques. All right, let's look at one example. So they're asking us to simplify the ratio cotangent theta over cosecant theta. All right. So in this case, they're asking us to simplify this by rewriting in terms of sine and cosine. Well, what are we going to do? So we're going to use a couple of identities here. So for cotangent, we're going to look for an identity for cotangent that is written in terms of sine and cosine. And we have this quotient identity here. So cotangent is cosine over sine. And well, cosecant, well, there's no ratio identity, but we can write that cosecant as 1 over sine. And that's what I'm going to do now. Well, this one is going to be cosine theta over sine theta. Divide all that by 1 over sine theta. All right. And I'm going to put parentheses around each of the fractions just so you can easily see how are we going to work on this one, right? So again, keep in mind that when we divide a fraction by another fraction, we keep the first fraction and we multiply by the reciprocal of the second fraction. And look what's going to happen here, which is really, really nice. Sines are going to go away. And in the end, we're going to be left with cosine divided by 1, which is simply cosine theta. All right. So that's one first example in which we are being asked to simplify, right? So cotangent, cosecant, those are typically a little bit complicated to work with because cotangent and cosecant, they have restrictions if you keep in mind their domains and their ranges and all that. Well, cosine is a nicer, it's a way nicer function to work with. So, all right, let's look at another example. Let's see what do we have over here. Well, show that cosine theta over 1 plus sine theta equals to 1 minus sine theta over cosine theta. All right. So what are we going to do here? Essentially, when they ask us to show that this equals that, we have to work on one side of the. Typically, we work from left to right. So we are going to manipulate the left-hand side and make it look exactly like the right-hand side. So I'm going to rewrite cosine theta over 1 plus sine theta. Okay, so what am I going to do here in this case? Well, here is where multiplying by a 1, where is it? Multiply the numerator and the denominator by 1, typically conjugates. Well, this is where this technique is gonna come into play. So what do we mean by a trigonometric conjugate? In this case, the trigonometric conjugate of the quantity in the denominator. So 1 plus sine theta, 1 sine theta. But in this case, the conjugate would be the sign that is opposite to the one that we have, in this case, minus or negative. All right. So this is what we are going to have over here. Here what we're going to do, we're going to multiply across. That's going to give us simply cosine theta times 1 minus sine theta. And I know what you might be thinking. We would have to distribute this. Well, wait, let's just wait for what's coming up. All right. And, 1 plus sine theta, 1 minus sine theta. If you look at this, well, if we pay special attention to this form, we basically have some form a plus b times a minus b. All right, which is in essence the factor form of a difference of squares. All right. So what are we going to do? We're going to write 1 squared, which is 1, minus the quantity b squared, which is sine squared. All right. Well, it looks like we're making this a little bit more complicated than it actually is. And well, not necessarily. Well, before moving on, let me just stop by. Let me just take a couple of steps back to the Pythagorean identity as well. From these three identities, we can obtain 2 more identities. For example, from the first one, if we move cosine to the right-hand side, we can have sine squared theta equals 1 minus cosine squared theta. On the other hand, if we move the sine squared quantity to the right hand side, we can have the following identity, which in this case is cosine squared theta equals 1 minus sine squared theta. And we can do the same for these other two identities. However, in particular, we are going to be in the need of using this identity here to move on through the exercise that we are working. For example, in this case, we are at the point in which 1 minus sine squared equals cosine squared. So we are really using one of the Pythagorean identities to keep moving. So this one will be cosine squared theta. And this is going to be cosine theta in the numerator. That remains the same. Alright, and look what's going to happen here. So this cosine right here will be cancelled with one of the powers there. And we're going to be left with 1 minus, actually, this was supposed to be minus. This was supposed to be a minus 1 minus sine theta over cosine theta, which is exactly what we wanted to show, isn't it? It's right here. That's what we wanted to obtain. Alright, let's look at another example. Well, simplify 1 plus sine u over sine u plus cotangent of u minus cosine u over cosine u. Well, in this case, what are we going to do? So, you might recall what we used to do back in elementary arithmetics. You know, like when we have 3/4 plus 5/3. Well, we would multiply this by 3 and this by 4 to have a common denominator. You know, so that's a 9 over 12 plus 20 over 12, and that's 29 over 12. All right. So basically, we're going to do the same here, but we are going to look for least common denominators in terms of trigonometric expressions. So that's going to be 1 plus sine u over sine u. I'm going to leave some space for those missing factors, the same way I did it in the numerical example. Cotangent u minus cosine u divided by cosine u, and in this case I'm going to multiply numerator and denominator by cosine u and multiply the numerator and the denominator of the second expression by sine u over sine u. And that's going to make the same denominator. Sine cosine is the same as cosine sine. Doesn't matter. I mean, it's a multiplication, so that's going to be the same. Alright, once we have the least common denominator, I'm gonna draw a big bar in which I'm going to multiply 1 plus sine u, which is the first factor, times cosine u, which is this one in red. Okay, and then plus cotangent minus cosine times this sine u. And the whole thing being divided by the least common denominator, which is sine u cosine u. Alright? So, well, in this case, well, yes, you guessed that right. So we need to distribute and distribute. Of course. Cosine times 1, that's cosine. Sine times cosine, that's cosine. Or rather, sine cosine. Let me actually fix this real quick. Sine. And then cotangent times sine, that's sine cotangent. Oh, I'm going to run out of space here. I think I'd better write it I'd better write it over here. So cosine u plus sine u cosine u plus sine u cotangent u, and minus cosine u sine u. Well, we write sine first. It doesn't matter. And then the whole thing divided by sine u cosine u. Okay, so looking at this huge expression, it looks like we have like terms that we can get rid of, like sine u cosine u minus sine u cosine u. Goodbye. They go away. And we are going to be left with simply cosine u plus sine u cotangent u over sine u cosine u. All right. Let's see. Let's see what else can we do. So, I mean, we could cancel one of the signs here if only we had two signs here to factor it out as a GCF and then cancel it out. Unfortunately, we cannot do this, no, because this is part of a sum. It is the same case for cosine. Right here, we cannot cancel this guy because it's part of a sum. Otherwise, if this were a cosine on the other hand, well, in this case, we factor it out as well, and goodbye. However, we're in a way we're trapped, but not for too much, not for too long. This is what I'm planning on doing. Well, in this case, well, notice we have everything in terms of sines and cosines except this cotangent u. That's what I'm going to focus on. So writing the cotangent as cosine over sine, as established in this identity, cosine over sine. And yes, it's gonna look a little bit ugly. Sine u cosine u. Okay, so something nice is gonna happen. Look what's gonna happen here. Number one, sine over sine, that's gonna go away. In this case, we can do it as opposed to over here, because here they're multiplying, dividing. Well, they belong to the same order of operation. So, and then we're gonna be left with cosine plus cosine, which is two cosine over sine u cosine u. And in this case, we can notice how this cosine u goes away with that cosine u. And that's going to be 2 divided by sine of u. And that's the simplest this can go. All right. So that's pretty much about it. It's pretty much about this this example. Or, well, if you prefer to move it into the numerator, this is the same as 2 cosecant of u. That doesn't matter. All right. Let's look at another example in which we are required to simplify. Sine squared of v minus 1 divided by tangent v sine v minus tangent v. All right, what about it? Well, so now we're going to look at a different technique to simplify this. We're going to look at factoring. And in this case, well, notice we have a difference of squares, something like a squared minus, well, the number 1 is a perfect square, right? 1 square is 1, so we can treat it as a difference of squares. And that's going to lead us to have the following. Well, a minus b, a plus b, that is sine v minus 1 times sine v plus 1. And then in the denominator, we have a common factor of tangent v. Tangent v times sine of v minus 1. All right. And in this case, we can see that we can get rid of these two expressions. And, well, that's going to leave us with sine v plus 1 over tangent v, simply tangent v. Alright, according to my notes, this is pretty much a final answer, but I mean, if you would like to go the extra mile, you might want to rewrite this tangent in terms of sine and cosine. So that's sine v plus 1, and that's sine v over cosine v. Actually, I got this example from the textbook, and that's what they do. They stop here. And of course, we can still go a little bit further and multiply, dividing by a fraction, multiply by the reciprocal, sine v plus 1 over 1. That's what I'm going to do here. Multiply by the reciprocal, cosine v over sine v. And that's simply, well, I'm not going to distribute this. I'm just going to write cosine v times sine v plus 1 divided by sine v. So either way, actually, or that one, either way, they're good. So depending on the need. Let's do one more simplification problem here. So in this case, I'm going to do the, what's this called? The conjugate, the trigonometric conjugate by multiplying by the conjugate of, in this case, the numerator, right? So in this case, 1 plus sine theta over 1 plus sine theta. And in this case, well, that's a factor form of a difference of squares. And I'm going to go here so I don't overlap that over there. So that's a 1 squared, which is 1 minus sine squared, divided by cosine times 1 plus sine. And well, 1 minus cosine, we already used that in the example at the top of the page. If you go back, 1 minus sine squared, that's cosine. All right, cosine squared. So the numerator becomes cosine squared theta. And that's cosine theta 1 minus sine theta. And in this case, we can cancel out this cosine with this squared, leaving us with cosine in the numerator and 1 minus sine theta in the denominator. All right, and that's pretty much about it. All right, let's look at another example. In this case, well, establishing identities. Well, we already kind of did that, establishing identities in a way, you know. So because when we, on the example in which we were asked to show that this equals that, what we did is work on the left hand side, do manipulations, and turn it into whatever is on the right hand side. And this is what we're going to do for the rest of this section. All right, so well, let's see, where do we start at? First of all, we start by the best way to go about this one. Well, it's let's recall the techniques. Notice this is infested of cosecants, tangents, secants. So it would be a good idea to rewrite this in terms of sines and cosines, which is the first technique that they taught us over here. All right, so let's okay, so we're gonna work only on the left hand side. We're gonna leave the right hand side alone. All right, so I'm gonna write cosecant as 1 over sine, and then I'm gonna write tangent as sine over cosine. All right, and that's still secant theta. All right, so I'm going to be copying, manipulating the left hand side and make this look like, well, actually, never mind. I'm going to do it the other way. I'm not going to care about the right hand side. All right, and notice what happens here. Sine and sine cancel out, and I'm left with 1 over cosine. Okay, but 1 over cosine, according to our identities, to our reciprocal identities, isn't that secant? So this is equals to secant theta, and that's what we wanted to show, right? Isn't it? The right hand side, of course it is. Of course it is. All right, let's do another example. Letter B, sine theta times cotangent theta plus tangent theta. Let's see what about this one. All right, the first thing I can think of, number 1, is, let's see, distribute. Let's see if that takes us anywhere. So that's going to be sine theta times cotangent theta plus sine theta times tangent theta. And what I'm going to do, so again, I'm only working on the left hand side. I'm going to do some manipulations and then eventually get secant theta. Sine theta, well, sine theta is simply sine theta. But cotangent theta, according to our Pythagorean identities, well, that's cosine theta over sine theta. And this is going to help us simplify this over here. But let's see what about the rest of the problem. Well, that's a plus. And in this case, sine theta again times tangent, which is sine theta, over cosine theta. All right, let's see what's going to happen. Number 1, goodbye sine. Goodbye sine. And that's simply cosine theta plus, in this case, it's going to be sine times sine, which is sine squared theta over cosine theta. All right, the only thing I can think of here is, well, let me actually erase this because I might need some space. So we say this was cosine. The only thing I can think of is thinking of this cosine over 1. Think of it as a cosine over 1 and multiply this by cosine. Divide by cosine. All right. And this way, well, cosine times cosine, that's cosine squared theta plus sine squared, or actually over cosine, and then sine squared over cosine theta. Now that we have the same denominator, we can write this in the form of one single fraction, cosine squared of cosine squared theta plus sine squared theta over cosine theta. Okay, what can we do over here? Well, if you notice, this cosine squared plus sine squared, which incidentally is the same as sine squared plus cosine squared. In this case, when we have an addition, it doesn't matter the order. Sine squared plus cosine squared equals to 1, or cosine squared plus sine squared equals to 1, doesn't matter. So we can replace this with 1. All right. So 1 over cosine squared, actually not squared, just let me lose my I lost my marker. Okay, just cosine. So, and let me highlight what am I doing. You know, this is being replaced with 1 by this identity here. All right. And in the end, what do we get? So we get 1 over cosine, which is the same as secant theta, which is what we wanted to show, isn't it? That's secant. All right, let's look at another one. Well, letter C. Well, letter C has a few of the negative angles, you know. So there are some negative angles involved. All right. So before doing that, be careful because in our over here in the even odd identities, sign of a negative angle is negative sign. We need to be careful. This is not true for any powers of it. So this is what we need. In order to simplify this one, we need to do something else. So this exponent, what it really means, I'm going to put brackets, sine of negative theta, close the brackets, square it, minus brackets cosine negative theta squared. And then, well, in this case, we can actually apply the even odd property of sine. So sine of a negative angle is negative. It's negative the angle. All right. It's it's negative sine of the positive angle. Now, what are we going to do in this case? Careful, we're not done yet with this. Well, sine of a negative angle, again, that's negative sine of the angle. And cosine of the negative angle is the negative disappears for cosine because that's an even function. And oh, I forgot the negative cosine over here. Well, the denominator remains the same. All right, well, be careful here because a negative quantity squared, that's going to be a positive one, isn't it? That's going to be a positive. So we're going to have negative sine quantity squared. Well, that's going to become positive sine squared. Then minus cosine squared divided by negative. In this case, what I'm going to do, actually, I'm going to factor out the negative sign for now. And then, well, what's next? Okay, later in this chapter, we're going to look at this is actually an identity, but for now, we're going to treat this as a squared minus b squared, which is a minus b, a plus b, basically a difference of squares. That's how we're going to treat this. So, in other words, sine theta minus cosine theta times sine theta plus cosine theta, or the other way around, sine plus cos, sine minus cos, doesn't matter. Of course, it's a multiplication, right? And then divide by negative sine theta, open parentheses, and then plus cosine theta. All right. So in this case, sine theta plus cosine theta with sine theta plus cosine theta, actually, I should have used red, of course. And this is what we are going to obtain. We're going to obtain this negative sine theta minus cosine theta. All right, this negative sign, in the very end, we are going to distribute. And we're going to distribute this to obtain, well, I'm going to write the positive term first. So cosine theta minus sine theta. All right. And actually, there's well, in your PDF file, it's going to be updated. But this one, it was supposed to be cosine theta and this one was supposed to be sine theta. Your PDF file is updated. In this video I just did that silly typo. And indeed that's what we wanted to show. Alright, so let's do one more. 1 plus tangent theta over 1 plus cotangent theta. Alright, yes, this one is gonna look a little bit interesting, and it's actually gonna be a lot easier than it looks. So this is what you might be thinking. Well, maybe changing this tangent as sine over cosine and this cotangent as cosine over sine. But in this case, our ultimate result, we want it in the form or in terms of a tangent. So what I'm going to do here is I'm going to change this cotangent, and I'm going to make it look in terms of tangent using its reciprocal identity. So 1 plus tangent theta divided by 1 plus 1 over tangent theta. All right? That's what we are going to do in this case. Well, then what we're going to do here is consider this as 1 over 1 and multiply by tangent, divide by tangent. We do that in order to be able to combine these two fractions together and be able to combine into a single fraction. So the numerator remains the same, 1 plus tangent, and the denominator becomes tangent plus 1, all right, divided by tangent. All right, this is the fraction that lies in the divisor. Dividing by a fraction is the same as multiplying by the reciprocal, in this case 1 plus tangent theta. I'm going to rewrite this as over 1 times, well, in this case, tangent theta plus 1 is the same as 1 plus tangent, isn't it? I'm talking about this 1 tangent plus 1 or 1 plus 10. It's the same. The reason why I am writing it in the reverse order is so we can see how these go away, because they're factors, right? And then tangent over 1, that's simply tangent theta, which is this guy, isn't it? That's what we wanted to show. All right, let's look at the very last page. We have a couple of very similar examples. Well, you might be familiar with these two expressions because we already worked with them. We already manipulated these two. So this one, take a deep breath, because that one is going to take a while. All right, so in this case we want to combine these two fractions together. Notice that we have two unequal or two unlike denominators. So what I'm going to do, let me write 1 plus cosine theta under sine. I'm going to leave some space here, plus 1 plus cosine over sine theta. And then what are we going to do? I'm going to multiply by the missing factor, so we have an LCD, sine theta. And for the second fraction, I'm going to multiply by 1 plus cosine theta over 1 plus cosine theta. All right, let me keep moving. So I'm going to draw a huge line over here, maybe a little bit longer. We'll see. And I'm going to multiply across on each numerator of the fraction. So sine times sine, that's a sine squared theta. Plus 1 plus cos, that's a 1 plus cos quantity squared. And in the denominator, we are going to have sine times 1 plus cosine. All right. So somehow this humongous mess has to look like simply 2 cosecant theta. How is that gonna look? How's that gonna look like? Is it gonna happen? Of course. Yes, it's gonna take a while for this one. Well, sine squared is simply sine squared. Okay, over here we have a binomial square. You might want to recall the formula for the binomial squared. A plus B. Quantity squared. If you don't want to FOIL, alternatively, you might want to rewrite as this quantity times itself and then FOIL, but simply a squared plus 2ab plus b squared. You might want to use that form as well, in which is basically square of the first term. Well, 1 squared is 1 plus 2 times the product of the first and the second, or in other words, these two quantities multiplied and then times 2. So that's 2 cosine theta, and then the second quantity squared, that's cosine squared theta. And then divide the whole thing by sine theta times 1 plus cosine theta. All right. Okay, let's see if we can simplify anything. All right, so I would like you to observe the following. If you notice, well, actually this one, let me make this one look more like a power. I think I wrote it a little bit ugly. Sine squared theta. Okay, so in this case, if you observe these two very closely, cosine and sine, cosine squared and sine squared, I'm going to put these two together just so you can see something. So sine squared plus cosine squared plus 1 plus 2 cosine theta. Alright, the whole thing divided by, well, I know what you might be thinking, should we distribute? No, we do not distribute this. So that's simply sine theta, 1 plus cosine theta. And if we recognize this identity, sine squared plus cosine squared, what's that? Well, let's go back to the first page. Sine squared plus cosine squared equals to 1. So this whole thing right here becomes 1. So that 1 plus that 1, well, let me actually just write them. 1 plus 1 plus 2 cosine theta over sine of sine theta times 1 plus cosine theta. I'm going to combine these two ones. 1 plus 1 equals 2 plus 2 cosine theta and sine theta in the denominator times 1 plus cosine. That doesn't change this at all. All right, now what's the next trick? We're almost done, by the way. We're almost done with this one. All we have to, I thought it was going to be longer than I expected. So we can factor out these two. 1 plus cosine theta divided by sine theta 1 plus cosine theta. Okay, what's going to happen here? Can you see that? Goodbye. Goodbye. So this is going to be 2 divided by sine. But what do we know about sine? That's the reciprocal of, we can move it up to the numerator as 2 cosecant theta, which is what we wanted to obtain over here, isn't it? This one. And that's what we wanted to show. All right. And let's do the last example for this section and call it a day, at least for this video. Alright, so in this case, what do we have? We have tangent, cotangent, secant, and cosecant. Well, we want to show that this whole quantity is equal to 1. Alright, so, well, in this case, I'm going to convert everything to terms of sine and cosine. Alright, let's see what about it. So I'm going to work with the left hand side as usual. Tangent, I'm going to rewrite it as, okay, let me rewrite it again. Tangent V plus cotangent V divided by secant v cosecant v. Tangent is the same as sine over cosine plus cotangent, which is cosine over sine. The whole thing being divided by secant, which is 1 over cosine times cosecant, which is 1 over sine. All right. What about this? This example? What about this expression? Well, number one, in the numerator, I'm going to multiply the first fraction because I would like to combine these two fractions together so we can perform a division first. So first we combine this to a single fraction and we multiply by sine in the numerator and the denominator as well. For the second fraction, I'm going to multiply by cosine. All right. And well, this is going to be this will become a new fraction in which the denominator is sine v cosine v. All right, and that's going to be sine times sine, that's sine squared v, plus cosine times cosine, that's cosine squared v. And in the denominator, all I'm going to do is multiply across 1 times 1, that's 1. And in the denominator, I'm going to multiply cosine times sine, which is the same as sine times cos. Sine v, cosine v. Either way is fine, but preferably because I think I know what you are going to, where are we going essentially. So you might want to just cancel this, but I mean the more formal way to show this, keep in mind. So dividing by a fraction is the same as multiplying by the reciprocal. So in this case, I know this is 1, but I'm gonna keep it for a second. Sine squared v plus cosine squared v over sine v cosine v equal, actually times the reciprocal of this. The reciprocal of 1 over sine v cosine v is sine v cosine v over 1. And in this case, what do we have? Well, cancel this out, divide this out, and this guy will become sine square plus cosine square becomes a 1. Why? Because of the Pythagorean identity, this one right here. So I'm going to have 1, the one in red, divided by 1. What is 1 over 1? 1, as we wanted to show, which is this one right here. Alright, so this is the end. I think it's a good place to quit. I'll see you in the next video.